Let me just share my entire desktop, I think. All right. Good morning, everybody. This is the first time I've done a user group before I've had my breakfast. So, welcome to Introduction to M. So I'm a colleague of Phil's on the Power BI Customer Advisory team. That's all the introduction I'm going to do of me. What are we going to talk about?
You're the new kid.
Yeah, I'm not the new. There's even newer people than me.
That's true.
So, what are we going to talk about? Well, like I said, there are going to be no pretty visuals at all. There is going to be no DAX. There is going to be just the Power Query editor and M. So we're going to talk about what the M language is and why you should care about it. We will learn the fundamentals of M. The good thing about M is that it is very, very simple. So an hour-long presentation will be all you need to learn the M language. We will have a look at maybe some more advanced features like creating functions. There will be a very brief look at web services and a bit at the end, streaming semantics. Well, I'll explain it when we get to it. But the first important question, what is M? M is the language of Power Query. Everything you do in Power Query gets translated back to the M language. What's Power Query? Power Query is the self-service data loading functionality that is used by Power BI and a number of other different tools. So not only Power BI uses Power Query, but Excel from 2016 onwards uses Power Query as its default data loading functionality. Other tools like more recent versions of SQL Server Analysis Services Tabular, data flows in Power BI use the Power Query engine. Power Query is turning up all over the place. I think most recently in Azure Data Factory, but it's hard to keep track of where it's being used nowadays. But basically, anywhere you see the Power Query editor, that means that you're using the M language somewhere in the background. Why should we bother learning M? Well, I would say if you're learning Power BI, it becomes pretty clear very soon that you need to learn DAX because there is no getting away from learning DAX when you're doing stuff in Power BI. M is slightly different. I would say that you can get a very long way in Power BI without ever needing to know or care about M. It's so well hidden in the background, and you can do so much stuff in the Power Query editor without writing any M at all, that quite honestly, it's something that you can kind of leave until you really, really, really want to prove that you're a true Power BI ninja. But, you know, certainly there will come a point where you think, well, it's time to learn a little bit of M, because there are going to be some things that you can only do through writing M. There are going to be some more complex transformations and pre-calculations of data that you need. There are going to be things like connecting to web services, which you can only do with M code. If you're feeling really adventurous, you might decide that you want to write your own Power BI custom connector, and that's something that you can only write in M. Personally, I really like M as a language, so it might well be something you do because it's fun. Personally, I think M is lots more fun than DAX, but don't tell Phil I said that. All right, let's get on to the more practical things. Where do we write M? There are a couple of different places where we will write M. So first of all, let's concentrate on writing M in the Power Query editor. So if I find Power BI Desktop and we click on Edit Queries, here we are in the Power Query editor window. So this is where we're doing all of our query editing. Let's connect some data. So I've got a CSV file here called positions demo. It's just got some very basic sales data in. We've got a month column and a sales column. Click OK. And there is a query. So where do we write M? Where can we see M? The first obvious place is up here in the formula bar. Now, you might not see the formula bar straight away. If you go to View, you have to have the formula bar box ticked up here. And when you've got that ticked and you have a query open, you click on a step in the query and you will see the M code for that step up here in the formula bar, and you can edit it here. This is a concept that we will come back to later, so don't worry about what a step is or what this code might be. Just know that you can see it at this point. The second place that you can see and write M code in the Power Query editor is if you go to Add Column and then click this Custom Column button up here. So this allows you to add a new column onto an existing table. I click Custom Column. I can type something in here, and everything that goes in this box is M. Click OK. There is my new column written in M. The final and perhaps the most useful place you can write M is in the Advanced Editor window. Now, in the Advanced Editor, you go, well, to open the Advanced Editor, you need to go to the View tab, click Advanced Editor. I do this so often, I've got this button pinned up here onto my Quick Access toolbar, so I'll be clicking there in the future. But if I click the Advanced Editor button up here, the Advanced Editor opens, and you can see the whole M code for this query that I've just generated. So every single step, including that new add column step here, everything has been translated into M, and I can see the whole M query, and I can edit it here. I could delete everything, and I could write from scratch. So those are the three places that you'll be using M inside the Power Query editor. A few other places. If you're using data flows, you can open up the Power Query online editor in data flows. You can write your M there. There's an advanced editor there, and indeed, if you want to have a quick tip for working with data flows easily, it's usually, I find, easier to write your Power Query queries in Power BI Desktop, and if you want to turn them into a data flow, you just open up the advanced editor, copy the M code, go to your data flow, open up the advanced editor there, paste in there, and bingo, you've got your M code for your data flow. If you want to write custom connectors, you can download the Power Query SDK. My browser window, oh, I've gone past it. There we go. So there is a Power Query SDK that you can download from the Visual Studio Marketplace. It only works with Visual Studio 2015 and 2017. I believe you can hack it to work with Visual Studio 19. I'll also point out that it hasn't been updated for almost a year, but the team are still working on it. This is intended for people who want to write Power Query custom connectors to add new data sources to Power Query. It does also allow you to write and run any M query inside Visual Studio. So it could be quite useful in other scenarios as well. And then apart from that, there is an extension for Visual Studio Code that allows you to write M. I've got my crib sheet here for the demos. This is the Visual Studio Code extension. I think it looks quite nice, and I find it quite easy to use. The bad thing about this is that this does not allow you to run any M queries. It just allows you to see M code highlighted in the appropriate colors and indented. And then the last thing is, if you use Notepad++, a guy called Lars Schreiber out in the community has written an M language extension for Notepad++. So let's get on to actually learning some M. Like I said, M is a really simple language. There is not much to it. In fact, M is so simple, a lot of the things that you might expect from a programming language don't exist in M. Things like loops do not exist in M, which sometimes make it a little bit difficult to learn for people who've got a background in other programming languages. M is a functional language. So if you've done any programming functional languages, you might find M a little bit easier. M is case sensitive, boo, which causes a lot of problems as well. But now we've got IntelliSense in the advanced editor. That means that it's less of a problem than it was before. It is important to point out that M is not DAX. Lots of people get confused about Power BI having two languages inside it, which I agree is not the nicest situation to be in. But M is all about data transformation and preparation. DAX is all about calculations once the data has got into your data set. The last important thing to point out about M is that once you start writing M, you don't need to write everything in M. The good thing about M and the Power Query editor is you can mix and match. Generally speaking, when I find that I need to write a bit of M, I don't write a complete query from scratch. What I do is I just click the buttons in the Power Query editor UI to get something approaching the query that I want. Then I go to the advanced editor, start doing some typing, write my own code to alter and update the code that's already been generated. And then I can just flick back, and most of the time, the Power Query editor window will still work in exactly the way that it did before. Even if it doesn't work perfectly, it'll work more or less well. So you can always just mix and match between using the UI and writing M code. That's what I find the most productive way to work. So that's what I'm going to be doing a lot of in this presentation. So let's finally get round to writing some M. In the Power Query editor window, we've got queries. If I go back to the Power Query editor here, this positions demo thing here that I created by connecting to a CSV file is a query. I can have as many queries as I want. Every query in the Power Query editor window is a single M expression. When the query runs, the expression is evaluated and a value is returned. And that's the value that, in a lot of cases, gets loaded into your data set. Now, every query returns a value of a particular data type. Positions demo here, like most of the queries that you'll generate in the Power Query user interface, returns a table. And you can tell that it returns a table because we've got this little table icon on here. Now, I'm going to leave this positions demo query here as it is, and I'm going to create a new query. You can create a new query for writing M by going to New Source and clicking on Blank Query. It's called Query 1. If I click on the Advanced Editor, you'll see that it's not really a blank query. So I'm going to delete all of that. So I've got a genuinely blank query. And let's write our first bit of custom M code. What's the first program that we write in any language?
Hello world.
That's right, hello world. There we are, there's hello world in M. That was particularly difficult. Click done. I click done. My query is evaluated, and we've got a query that returns hello world. This query returns a text value. You look at query 1, look at the icon here. You can see that it's got an ABC icon here saying that we're returning a bit of text. Let's edit this query. Let's do something a little bit more challenging. Here's another M expression, 1 plus 1. What do you think this is going to be returning when I evaluate it?
2. Integer.
You see, I was just reading in the newspaper that New Zealand has got the best education system in the world. And the amount of time it took for you guys to tell me that 1 plus 1 is 2 is quite...
We're shy of the line.
We've got the worst internet in the world. There's a really terrible delay.
Well, I have to say, you kind of replied hello world pretty quickly to the first question. And then it's like, anyway, it returns 2, as you might expect. So there we are. All right. We've got queries, they're evaluated, they return expressions. And I know what you're thinking. You're thinking that, all right, that makes sense, but we were looking at the advanced editor for this. There is no way that all of this is a single expression. It is. It is through the magic of let statements. So let expressions, let statements, whatever, are the key to doing more complex things in M. A let expression allows you to break up a single expression into multiple easier chunks. So let's write a let expression. Let's edit this query here. Let's delete. Now, this is where I wrestle with IntelliSense because I always have to remember to press space after I've written let, because otherwise it gets confused. Can everybody see? I don't need to zoom in or anything when I do write code, do I?
That looks good.
No, that's good.
All right. Yeah, you're on a nice big screen, I hope.
Yeah.
Okay. So this is a let expression. It's got two parts. It's got a let clause and an in clause. In the let clause, what we have is a comma delimited list of variables and the values we assign to them. So let's write a comma delimited list of variables. Here's my first variable. I'm going to call it step 1, and I'm going to give it the value 5. It's a comma delimited list, so let's put a comma in here. My second variable is called step 2. We'll put the value 10 in here. And my third and final variable is going to be called step 3. And in my variables, I can refer to the values of other variables. So step 1 times step 2. So we've got a comma delimited list of variable declarations. In my in clause here, I have an expression that when it's evaluated will be what my let statement returns. Now in my in clause, I can write whatever I want, but in this case, I'm going to write step 3. So step 3 is what I'm going to be returning. People of New Zealand, what do you think this is going to return?
50.
Don't think that laughing is going to give you like that extra precious few seconds to kind of get you out of thinking about your multiplication. Click done, and you're right. Have a gold star. You get 50. Now, that was all pretty straightforward. There are some things to point out. Look on the left-hand side. The 3 variables have been turned into steps inside my query. In positions demo, I've got steps in the applied steps pane here as well. So pretty much every single query generated by the user interface will consist of a let expression like this. The steps in the query will be the steps that we've got here. The variables that we've declared. Now, a few other things to point out about this. If our variable / step names need to have spaces in, so let's say that we wanted to put a space in between step and 3, I can do that by putting a hash, double quotes, variable name, close double quotes. So now I've got a variable called step 3 with a space in. The double quotes are necessary because I've got a space. The hash in front tells me that this is a variable name and not a bit of text. When I click done, that's just given me a space in between the step and the 3. So that's a pretty common thing to do. Something more interesting to note, and this is something we'll come back to right at the very end. This looks very much like procedural code. And that assumption is the most dangerous assumption you can make in M. Because the Power Query engine doesn't evaluate step 1 first, then step 2, and then step 3. It evaluates things from the end backwards. What do we want out of our let expression? We want the value of step 3. That's the first thing that gets evaluated. What's step 3? Well, step 3 is step 1 times step 2. So step 1 and step 2 have to be evaluated. The Power Query engine always evaluates things from the end backwards, not from the beginning forwards. And when you remember that, that will help you understand a lot of very confusing concepts in the world of Power Query. It also helps you understand why the order of the steps is irrelevant, because I could do this. I click done, and I still get 50. You'll see it messes up the applied steps pane, because as soon as I do things out of order, the Power Query user interface isn't able to work out which order things should be in, but the query itself works absolutely fine. So I can do anything in any order whatsoever. What's important is what I'm returning, and that will give me a list of dependencies. I could change this to be step 1, click done, and that returns 5. In this scenario, well, I only want the value of step 1. So what's step 1? Step 1 is 5. In most cases, this and this won't even be evaluated because I don't need it for the end result. It's not quite as simple as that, but more or less you can think about that as being what happens in most cases. So this means that we can go back and have a look at the query for positions demo and understand a little bit more about what's going on in here. So remember, this is the query that was generated purely in the UI. But if I go to the advanced editor, what have I got? I've got a let statement. What am I returning? I'm returning the added custom step variable, whatever you want to call it. All of these hashes look a little bit intimidating, but we know now that they are just there because we've got spaces in these step names. There are lots of functions hanging around here. We'll talk about functions in a moment. But basically, what's added custom? Well, we're calling the table.addColumn function, which is a function that takes a table and adds a column to it. We saw that it added a column called custom with a value 1, 2, 3 in. What's this? Well, this is the table that is returned by the change type step. There's another function here, but this works on the promoted headers step, which is defined here, which, well, that works on source, and that's defined here. So we can now read a simple query generated by the UI. Going from the end backwards, we can see the dependencies. One last thing to mention. We've seen that in queries, we've got variables. We can refer to any variable that we need. We can also, when we're writing queries, refer to the output of other queries as well by name. So here I'm editing query 1. I can just say positions demo here, which is the positions demo query. I click done, and now query 1 returns the output positions demo. If you come across the referencing button inside the Power Query editor, that's how that works. So I can refer to the output of any other query here inside my M code just by referring to it by name. Right, let's move on. Let's talk a little bit about data types. This is kind of unavoidable. It's the dullest part of the presentation, but it's unavoidable if you want to do anything useful in M. In M, we've got all of the obvious primitive data types. We've got numbers, we've got text. We've seen how you can write numbers and text in M. If you want to use dates or durations or date times or something a little bit more sophisticated, there are some built-in functions that will allow you to generate values of these data types. So for example, if I want to write a date, there is a hash date function that will allow me to create or declare a value of type date. So if I say 2019 7/30, this will return a value of data type date for today's date. It's still the 30th in New Zealand, I think, isn't it?
Yep.
For the moment. There we are. So there's a value of data type date. You can see that it's a value of data type date because we've now got this date icon here. So there are various other implicit functions like this that will give me values of a certain data type. But there are three really important structured data types that you need to know about in M. They are lists, records, and tables. So this is where we start coming across lots of square brackets and curly brackets. And this is where I'm going to go to my crib sheet. Let's talk about lists first of all. Lists are simply ordered lists of values. Here's a list. It has 3 items in it, all 3 of which are text values. Apples, oranges, and pears are 3 text values. This is a list, so this is an ordered list. So apples is first, oranges second, pears is third, and that's guaranteed. You can see that it's surrounded by curly brackets. I click done, and now I've got a query that returns a value of type list. So when we've got this, the Power Query Editor has a special list tools dialog that opens up. I can turn this into a table. I can remove items, but basically it's just something a bit like an array. But yeah, there's not that much to it. A few other things to mention about lists. Lists can have lists as items in them. If we go back to here and we look at this list, this is a list with 2 items in. Here's the first item, here's the second item. Both of the items are lists. I click done. There's my list. Item 1 is a list, item 2 is a list. If I want to have a sneak peek of what's inside the list, instead of clicking on the link here, what I always do is just click inside the cell, and it will show you in the preview area down here the contents of the list. So I can have lists inside lists. If I want to declare a list of numbers or a list of any other value, that's pretty easy. I can just do something like this. It's a list with the values 1, 2, and 3 in that order. If I want to declare a range of values, this works for numbers and it works for a couple of other data types. Let's make this 7. This will give me a list of all of the values from 1 to 7. So that's lists. They're kind of like arrays. They're just ordered lists of things. The second important data type to think about are records. You can think about a record as being something like a table with 1 row in it. A record, and here's an example of a record, is written as a comma delimited list of fields and the values associated with the field. So here's a record. I've got 3 fields, speaker 1, speaker 2, and attendees. Here's my field name. Here's the value associated with that field. Here is the second field name. Here's the value associated with that, and so on. And a record is written and enclosed with square brackets. So I click done, and there is my record. You can see there's the icon for a record, and there are my fields and the values. And once again, I've got a record tools part of the ribbon that appears when I'm looking at a record. So tables, that's records and lists. The most important structured data type, though, is the table. And in a way, you can think about a table as being made up of lots of lists and lots of records. Let's see what I mean by that.
Chris, quick question. So for columns, there's nothing specific for column. A column of a table is a table.
A column is just a part of a table.
Right. Okay.
As I'll show you in a moment, you can think about the columns in a table being a series of lists, or the rows in a table being a series of records. but I'll come to that in a moment. So let's generate a table. There is a hash table function. I always get confused, Americans, when I say hash, but I mean hash in the UK English sense of that being a hash, not a pound sign, but I'm sure you understand what I mean. There is a hash table function here that can allow me to generate a table. There are two different variants of it. I put some line breaks in here. I declare a table. I give it, first of all, a list, which is a list of all of the column names as text values. Then I have another list where there is one item in a list for each row. And then for each row, I use a list to declare the values in there. So I'm going to have a table with 3 columns called A, B, and C, 2 rows. Those are the values in there. Click done. And there is my table. You'll notice that all of the columns in the table have got this ABC123 icon, which means that we don't know what the data type is. This is the any data type that usually when you see it, you want to get rid of and actually set a data type. There is another variant of the table function, which is a little bit more complicated, but which allows you to define column types up front. So the only difference here is this first parameter, which declares a table data type. This is not something we're going to be going into in this presentation, but basically this is a way of saying I'm going to have 3 columns, A, B, and C, which have data type number, and there are my rows declared in exactly the same way as we did before. And there is my table with 3 columns of type number. Now, I'm going to move on a little bit, but bear in mind what I said about tables being something like a whole bunch of records or a whole bunch of lists. We can extract individual values from lists, records, and tables by using the positional operator and the lookup operator. This is actually a lot less complicated and scary than it sounds. Go back to my M examples up here. What we can do is we can say, let's get an individual item from a list. Let's make things a little bit easier. Let's go up to here. Let's get a let expression. All I'm using the let expression for here is to have fruit numbers easily available. But if I was to say, give me an item from my numbers list here, which remember is all of the numbers from 1 till 5, I'm asking for the number at the index 2. What am I going to get here? Well, I'm not going to get the number 2. I'm going to get the value 3. Because, as well as being case sensitive, of course, M has all of its indexes starting at 0. So when I say 2 here, that means give me the 3rd item from the list, and 1, 2, 3, that's the 3rd item from the list. If I was to say fruit 0, that's going to give me apples. If I was to say fruit 2, that will give me pears, the 3rd item in the list. If I was to say fruit 20, this will give me an error because there weren't enough elements in the list. But if I say 20 question mark, that will give me a null value. The question mark just allows me to say, well, if I'm out of range, just return a null anyway. So I can get an item from the list using this curly brackets notation. So give me the nth item from a list. I can get a field from a record as well. So if we go to my record that I was showing you a little bit earlier, let's paste that in here. There's my record. give me the field name speaker1 from my names value up here, which is a record. And that will give me the value for it. And then the final thing to show is that I can get lists and records from a table as well. Let's look at this in a little bit more detail. So my source variable here is that table. It's the table with the columns A, B, C, and 2 rows in. Now this square bracket operator is how I was getting an individual field from a record. But source in this case is a table. And if I say give me A in square brackets, we'll see what it means. It means give me all of the items in the column A. So I can get the column A as a list of all of the values in that column. If I change this and put some curly brackets here and give me curly bracket 0, this is going to give me the first row, which of course consists of the values 1, 2, 3, and there's a record with 1, 2, 3 in. I can put these things together, have my curly brackets and my square brackets, and say give me the first row and give me the value in field A, which is going to give me the value 1 in this case. It's going to be a way of getting an individual value. If I in fact get rid of this, I can do this in the UI without actually typing any code. If I want this value 5, I can just right click and say drill down, and you can see indeed the UI has generated the same code as I had before. So I can get individual values from tables, records, and lists. Let's try and do something vaguely useful with this. Here's my positions demo table. I'll just remove that custom column. Let's imagine that we want to do a more complex calculation on here that we can't do in the UI. Now, the calculation I'm going to do is not necessarily one you really want to do in M, and it's not going to be one that you want to do in M in the way that I show you, but it will give you an idea of how you can use these concepts. Let's pretend we want to do a previous month growth calculation. So we've got one row for each month and the sales for each month. And what we'd need to do for this calculation is a way of finding out for each row, what was the value of the previous month. If we assume that the months are in order, and we can guarantee in M that the rows in a table will stay in the order that they've been brought in, then all we need to do is to find the value of sales on the previous row. So for February, the previous month's sales is 100, the value for January. How do we do this? Well, we can do this with a mixture of M and clicking on the right buttons. The first thing I'm going to do is I'm going to add a new column to this table and add an index column starting from 0, which gives us a row number. And very important, starts from 0. The next thing I'm going to do is I'm going to add a custom column. And this is where I'm going to get my previous month sales value. How do I get the previous month sales value? Well, what I want to be able to do is to be able to say, well, give me the current row and give me the sales for the previous row. In order to have a current row or previous row, I'm going to have a table that I can look up against. Now, I'm going to create a new step here with this custom column dialog. What I want to do is look up a value from the table returned by the previous step. And as we saw, the previous step is called added index, and I can refer to the previous step by writing added index. So that will give me the table returned by the previous step. I want a value from the sales column, and I can get the sales column from that table by using this square brackets notation. This gives me a list of the values from the sales column. And then I want the value in the sales column from the row before the current row. And I can do that by saying, let's look up a value in that list. Let's look up the nth item in the list, which the n is the value returned by this index column, subtract 1, close my square brackets, and this will be enough to give me my previous month's sales. Click OK, and there you can see that 100 goes to there, 202 goes to there, 304 goes to there. We've got our previous month's sales. So this gives you an idea of how these square brackets and curly brackets get used. If we actually have a look at the M code, you can see that even in the code for all of the previous steps that we didn't really do anything with, there are square brackets and curly brackets all over the place. In the source step, where we're loading the data from a file and making it into a CSV document, you can see that CSV.document function takes a parameter, and that's a record. Lots of M functions take records as parameters that allow you to pass variable lists of options in. Every time you see square brackets, think records or getting fields from records. Every time you see curly brackets, think lists. So that deals with records, lists, and tables. We've got another problem we need to deal here, which leads nicely onto my next topic, which is dealing with errors. We've got an error here because we're asking for the -1th item from a list, and that doesn't exist. How can we handle that? Well, we've got some options here in the UI. I could right-click and remove errors or replace errors with another value. With M, I have a third option which isn't available anywhere in the UI. If I edit my added custom step, this is the expression that at least on one row returns an error. If I want to handle errors, I can do so using a try otherwise block. I can write try and then an M expression. And if that M expression works, I'll just get the value of the expression. And I can put otherwise. And if this M expression returns an error, this will be activated and I'll get 0. Click OK. And there's my error handled. So error handling is very easy using try otherwise blocks. Let's talk about functions very briefly. So we've already seen that M has lots and lots of functions built in. These are the functions that are used by the UI. If you ever want to see a list of all of the functions you've got available to you, let's open up the advanced editor here. Let's delete all of this. There is another implicit function called #shared. You just type this in and it returns a record where each field is the name of a function that you've got available, and the value of each field is a function or some other type of value. So this brings home the fact that in M, as well as data types, table, record, list, date, number, text, functions are data types as well. We can return values of type function. That's what's happening here. Something interesting to point out about this is that we're returning a value of type function for each field in this record. If I click on one of these cells to get a preview, I not only see information about the function, I can see its documentation. And quite often this documentation is more detailed or more up to date than what we've got in the online documentation. I'd like to point out, if you go to powerquery.microsoft.com, there is actually now a dedicated Power Query site with lots of information and links to the Power Query documentation and M language documentation, where you can see information about the language and all of the functions and so on here. But this #shared function is really useful if you want to get some documentation available offline. The M language has documentation built into it. Now, let's get on to more interesting things. These are the built-in functions. I can define my own function quite easily. Let's define a function. We'll take two values, x and y, that are numbers. We're going to return a number, and the number we're going to return is x multiplied by y. This is how you declare a value of type function in M. When I click done, query 1 here returns a value of type function. You can see this fx symbol here. That's the function value, the icon for a function data type. Let's call this query multiply two numbers. And now I've got a query called multiply two numbers, which returns a value of type function. If I want to test this function, I can put two numbers in here, click invoke. This creates a third query for me with a single step that calls multiply two numbers, the name of my query up here, passes in 6 and 7, and we get the value 42 back. So declaring and writing functions like this can be quite a useful way to kind of encapsulate more complex transformation logic that perhaps you want to share between multiple queries. We can call a function just by writing its name, putting it opening two round brackets, passing the values in that we want to pass in. And invoking functions like this can be quite useful. There's a more useful way to invoke functions though. If we go back to positions demo here, I can call a function once for each row of a table by going to add column, invoke custom function. So there is a button here that allows me to call a function once for each row in a table, but it's only custom functions. And in order to use this button, I have to have a query like multiply two numbers that actually returns a function. But if I click invoke custom function here, I need to choose the query that returns the function. I need to pass in values. I could pass in a value that I type in, or I could take a column that contains a number like sales. Let's pass in the value 2 here. And you can see that I've just multiplied the values in the sales column by 2. So I can use functions to call or to do more complex operations on each row of a table. Let's see another example of this. Let's do a little bit of cleanup here and delete this. I promised I would talk very briefly about writing using web services, and I will do so now. Web services are a fairly complex topic, and to be honest, a little bit dull unless you're really interested in web services. But they are one of those situations where you will absolutely need to write some M code if you want to use them. So here I've got a web service. This is a UK government web service that allows me to search for open data. I've got a query string here that says, let's search for open data about cows. This is an example of how to make a GET request against a web service. When I create a new blank query here and paste this in, I'm going to call web.contents with a URL. That will call the web service. It'll bring back a JSON document. JSON.document takes that and converts it into a record. And here is the result of my web service call as a record. So that's moderately interesting. I've got a more fun web service here that takes some text and translates that text to French. This horrible URL is in fact a Microsoft Flow URL. Very easy to create simple web services in Flow. So ignore the horrible large URL. Notice that the second parameter of web.contents that I've added here that wasn't there before is a record. And if I've got the second parameter and in my record I have a content field and I pass in a binary value, And text to binary takes a bit of text and converts it to a binary value. So if I have a binary value in a content field, the second parameter of web.contents, this allows me to make a post request and basically allows me to take some text, post it up to my web service. And what we'll see is when I run this, it translates my text into French. So there's the text translated to French. When we're working with web services, quite often a web service does something really useful and we want to call it more than once. So we can take this query and we can convert it to a function. All I've done here is copied this, and instead of hard coding the text, "Hello everyone, how are you today?" I've said, well, let's turn this whole thing into a function. We're going to pass in a value called input text, and that's going to be what we translate to French.
So, Chris, functions don't have names. Or am I
No,
missing?
functions are just data types, but I've got a query here which can return a value of any data type, and in this case, it's going to return a value of data type function.
But that function
So
doesn't have a name.
the function itself doesn't have a name. Functions are just data types. So I'm going to call this query translate to French. I've now got a function. Let's type in, let's see how it deals with New Zealand. It should give me Nouvelle-Zélande, and in fact it does. There we go. So I can take some text, translate it to French. And as I showed you, if I've got a whole table of values that I want to translate to French, I can do that using the Invoke custom function button. So let's edit some. Let's create a table. Let's put some things in here. Apples, pears, oranges, pineapples. We'll call this fruit. We've got a table of fruit names. Click OK. Let's again go to add column, invoke custom function. Let's invoke my translate to French function. The input text is going to be whatever is on the current row in the fruit column. Click OK. Notice we're getting that. And there we go. There are the values here. One very last thing to point out about this. We've been talking about functions a lot. You may have looked at M code in the past and wondered what this each is here. Each is an M keyword that allows you to create a function with no name, no declaration at all, but just it's a parameter, a function with no name that takes a single parameter whose name is underscore. So if I create a new blank query here, I've got an example of an each expression. So with an each expression, this underscore is whatever parameter the single parameter I can pass in. I'm multiplying it by 2. If I click done here, you can see that I've got this single optional parameter, type 5 in here, invoke it, and I'll get 10. So what this means is that every time you see an each expression, which you see all over the place in M code here, look, there's an each expression in that invoke custom function box. If we go to positions demo, there's an each there in our custom function or our custom column declaration. That's basically just defining a function with a single parameter here. And if you're wondering how I can get column name here, well, with this each expression on the added custom function, well, that's just passing in for each row. It's passing into this function the current row, and that underscore is optional, but that will give me just the current row and the sales column. from that current row. One very last thing in the last couple of minutes. Going back to that idea of M queries being evaluated from the end backwards. This is one of these concepts that I'll tell you, it'll sink in, but you won't really understand until it comes back to bite you later on. I'm going to leave with my favorite mind-bending M demo, which hopefully we've learned a little bit of M, or enough M to understand what's going on and feel give you something to think about tonight. Here's a query. I'm just going to paste it into here. We've got a let statement. Our first step is called source, and it's a list of all of the values from 1 to 5. Not much there. Second step, I am defining a function. The step's called wait_a_sec. The function takes a value x, and inside this function, all I'm doing is I'm calling a function called function.invoke after. This is a function that allows me to call another function, and then before I do that, wait. So all this is doing is it's saying, here's a function, takes a value x, and then afterwards, this will return the value x after 1 second. And this hash duration here gives me a data type of a duration of 1 second. So all this is a function where I pass in a value and it will return the same value after a second. So not much there. The third step, called call function, which is what I'm returning from my query here, uses the list.transform function to loop over each item in this source step and call the wait_a_sec function. So I've got 5 items in the list. I'm going to call this function 5 times. It's going to wait a second each time. And I'm going to get back a list which has exactly the same values in. This is not being evaluated because we're not returning it. So we'll ignore that for the moment. We'll call the query 5 times, run the function, and you will see that this is going to take roughly 5 seconds. Now, if I do this in the Power Query editor, it'll do it twice for reasons that I'm not going to go into, but you can see that it took at least 5 seconds, which all makes sense because I've got a list with 5 items in. I've got a function that you take a value, wait a second, return the same value, and I'm calling that function once for each item in the list. So it makes sense that it would take 5 seconds. Let's think about this last step here called first value. This uses the list.firstN function to get the first n items from a list. And I'm saying, give me the first one item from the list returned by call function. So I'm going to return whatever that first value step returns. And most people, when they look at this, will think, well, how do we read this? Well, we've got a list of 5 items, 1, 2, 3, 4, 5. There's our function. We're going to loop over every item in that list and wait a second each time. And then here, I'm just getting the first item from the list. The question is, how long is this going to take? Is it going to take 5 seconds again? If I click done, it doesn't. It takes 1 second. Because we're evaluating from the end backwards, and I want the value of first value. Well, that says give me the first n items from a list. What's that list? It's call function here. But the Power Query engine, because we evaluate from the end backwards, is clever enough to know that because I only want the first item from this list, I don't actually need to loop over all 5 items from the list. I just need to evaluate the first item in the list, which will involve calling this function once, which means that we only get a wait of 1 second and not 5 seconds. So this is what I mean by things being evaluated from the end backwards, and also not only from the end backwards, but different parts of each expression being evaluated. And this can happen, and this can even go back to the data source. The very last thing that I will show you is that if I connect back to SQL Server, I've got SQL Server running on my PC here, and I connect to a table called dim date and get all of the rows from that table and import it. And I select some columns. Let's remove other columns and select some rows. I've connected to a table in SQL Server. I've selected some columns, I've selected some rows, and I want just these columns and just these rows. The same thing has happened connected back to SQL Server, but that idea of just getting the data that I want, of working from the end backwards where I only want these columns and only want these rows, has actually even made its way back to the data source. And through a process called query folding, which is a story for another day, I can see that that final output of the query has been translated to a SQL query that asks just for the columns that I want and has a where clause that just gives me the rows that I want. So that's where I'm going to leave it. We've seen lots of interesting things here, but hopefully this is going to be enough to get you going with M and understand how M works. There's more to say about M. There are lots of interesting functions to explore. There are some more complex concepts with lazy evaluation and things which are really quite difficult to get your head around. But that's the basics of M, and I think that's going to be more than enough to get you going for the scenarios that you ever need to write M. And hopefully you'll agree that it's at least a little bit easier than DAX, but let's face it, nothing is harder than DAX, is it?
Right. I don't know, Chris. I've got you on record now as saying.
Around,
yes,
I know.
Yeah, sorry, Chris. I've got you on record now as saying that M is backwards. Is that what I can take away from this
yes,
session?
absolutely.
M is a backwards language. You going to be able to stick around for a little bit for questions, Chris?
Absolutely.
I'm sure we might
I
have
haven't
one
had
or
my
two.
breakfast yet, and it's 8 o'clock in the morning. But
Okay.
you know, just for you, Phil, just for you, I'm going to stick around a little bit.
Okay, we won't have many, I'm sure. And Dave in the other room, if anyone there needs to ask a question, then just take yourself off mic, and now's your opportunity. So we'll start with the other room first. Is there anyone in there that has a question for Chris? No?
It looks like a room full of people who've just been exposed to an hour of M code. So
maybe I could ask you. You had lists of things like tables. It seemed rather cumbersome to put data that way. Like usually we end up with 500,000 records there or whatever. And the way it seemed with how you generate tables, it seemed quite cumbersome. Any comments on that?
well, and what I would say is that I've done all of that manually. And usually, of course, the data you're working with is data that comes from a data source. So you don't see the fact that there are tables and records and lists. You know, you just click on a button, click to connect to SQL Server or whatever, and that generates those data types for you. They're there, and you can manipulate them in the way that I showed you if you want, but you know, usually you don't care about it because you're just connecting some external data source, and it just works.
Can I just check with you for the invoke functions, right? Is there any way that if let's say I just wanted to change the date for record, for example, like I want them to filter to this end of this month. So next month this month will be like 30th of July.
Mm-hmm.
31st July. Yeah, and then next month itself, I want to ask them to filter to 30th of August. So is there an invoke function that repeats this process?
So what do you want to do here exactly? What's the end result you want to achieve?
The end result is that every single month itself, they will look for the month. They will give me the date of that month and filter the FX rate.
Okay, so you only got the FX rates for the current month.
Yes, correct.
So the way you would do this is that there are functions in M that allow you to get the current system date time, and you can derive, you know, the month from that, and then you can use that when you're filtering. So you'd be able to create a step manually in this case, because there isn't a button to do it, to get the current date time from the system, derive the month from that, and then when you've got that, use that inside create a separate query for that, and then you'd be able to use a filter. You'd again be able to do that you'd have to do that manually and filter your main table of FX rates, so you only get the FX rates where the month matches the one that you just derived.
Okay, cool.
Cool.
Is there any? Sorry.
You go. Carry on.
So is there any caching of the function results? So say if you're calling that French conversion translation and you call it 500 times with the same phrase, will it cache that?
It will actually, yes. Now, in the case of, there are different levels of caching. Certainly the Power Query editor itself does a lot of caching of values, which is why sometimes you see that yellow bar coming up with, maybe displaying cached values. That caching only exists to make the Power Query editor run faster, but that doesn't apply when you're running the query. But having said that, with web services, the Power Query engine, when you're actually running a query and you're calling a web service, it will cache results as well. If it knows that you're calling a web service, and unless you write a bit of code to prevent it doing this, it will realize you're calling the same web service 500 times with the same value and only call it once and just use the cached value. But it will only cache that for the lifetime of that query. So yes, it will do caching as well. There are other clever tricks you can play as well. If instead of calling a web service 500 times, sometimes you can pass 500 values to a web service in a single call and get 500 values back. And it's possible to do that in M as well.
On the web services front, how mature is the authentication model? I know this might be going beyond the reason of this one, but for example, can you, if that web service is secured or isn't yours, are there options enough to pass an open ID or OAuth 2 or,
That's another good question. If you're writing M code in Power BI Desktop or Excel, the options are actually very limited. If you want to be able to work with most real world production web services, basically, regardless of whatever you see on the blogs, you're going to have to write a custom connector. For example, if you want to call anything with an OAuth 2 that uses OAuth 2 authentication, you have to use a custom connector because it's more complicated and there is some functionality in M that's available in custom connectors that isn't available inside Power BI Desktop or Power Query in Excel. And this is the functionality that is built specifically for handling the more complex authentication types.
Okay.
So you can do it. It may not be documented well inside custom connectors, but it is more or less always possible.
Cool. You got time for one more question, Chris?
Yeah, absolutely.
Yeah, maybe one more from this room.
I've got it.
Cool.
I've been working with a nasty one all day.
Okay, Jeff.
Table buffer, Chris. So I'm working in Excel, and I've got two tables, and I'm joining them, and I'm taking the matches out, and then I'm joining them again on date, and I'm offsetting the date by 1 every time because I want to, these tables might not match. And so I've got this long, and I'm doing this, 7 times because I want to catch all the matches within a week of each other. And I don't know why, but it needs table buffer around any time I'm referencing one of the previous queries. Can you explain a little bit about what's going on with table buffer? I understand the point of loading it into memory for the duration on that particular query, and people often go, it's only useful in that step, but evidently that's not the case.
Well, that's another good question. I think table.buffer is one of the kind of most widely misunderstood functions in the whole of M. But to understand why it's necessary goes back to that last demo that I was showing you. So the Power Query engine, in order to be able to work with large data volumes, deliberately tries to load as little data into memory as it can at any one time. That means that, if you're working with large amounts of data, it doesn't go to the data source, grab a large amount of data, copy it into memory, and then store it there and then move on to the next step. in the way that most people would think that the Power Query engine would do, because if it did that and you had a large amount of memory, it's just going to break your PC. It would work for 50 rows, but it wouldn't work for 500 million rows. So it does all kinds of clever stuff in the background where if it thinks that you've got a large amount of data, and it will just grab small pieces of it at a time as and when necessary. So think about that last demo I showed you where it was, I was saying, give me the first n items of the list and give me the first one. It was clever enough to go back and say, well, I only need to evaluate the first item in the list. Now, this can come back and cause problems when you're doing things like merges, where you will find that instead of materializing the entire table that you want to merge together in memory, the entire tables that you want to merge in memory, it will say, well, I'm going to do this at a kind of 200 rows or so at a time, which means that for every block of 200 rows where it does that merge, it's going back to the data source and grabbing the next 200 rows and the next 200 rows. So you end up reading the data multiple times from the data source, which ends up being horribly slow. Table.buffer simply says, don't do that. Materialize the tables you're working with in memory, and if they're already there materialized in memory, then when you do a merge, they're automatically there and it will just do the whole thing all at once. That can also end up being slow. It's not the solution to all your problems because the Power Query engine has quite low limits on the amount of memory that you can use for any one particular operation. It's limited to I think about 250 meg for any individual query when you're doing a refresh, and you could be there could be lots of queries involved. So table.buffer could end up with you trying to load a large table into memory, which blows this 250 meg limit, which means that then other types of paging happen to disk and go to disk, which ends up being slow. But yeah, in a lot of cases, table.buffer is the answer to all of your performance problems because it stops you from having to go back to the data source multiple times. And in a lot of cases, there's no way of even
the
knowing.
steps in the actual merge function. You go where it says merge table 1, you do wrap a table buffer around there. Do you buffer both of them or just one of them? Does it matter?
It depends. I would probably do both of them.
Okay, thank you.
But yes, it's a
in the indication of
answer.
speed. It's gone from I don't know, probably a day or it will probably take a day to execute. It's gone from that to 2 minutes.
Yes,
It's
that
incredible.
doesn't surprise me at all.
Okay.
Thank you.
Awesome. All right. Well, thank you very much, Chris. We'll let you get to your breakfast now. It was a very good presentation. I enjoyed it. So you'll give him a round of applause, I guess. And feel free to stop the recording, hang up, and we'll do our wrap-up stuff out here. And yeah, I'll probably see you online, no doubt, later in the week. So thank you very much.
Enjoy breakfast.
Thank you.
Thanks a lot, guys. Bye-bye.
Bye. Cool. So hopefully you can. Oh, you just hang up, Chris.
There you go.